Hello everyone. Once again welcome to PM Networking. Hope you all are doing great. Guys, today in this video we are going to understand what is uRPF. See, sometime interview is also asking this question in interview, like explain uRPF and tell me the scenario where I need to configure uRPF. So I'm going to make you understand first the scenario, the situation where you need to use uRPF, and then I'm going to show you practically like how you can configure it, right, to prevent the attack. This is a part of security, right? If you will check ccnp syllabus, so in your ccnp syllabus also this is one topic. So without wasting our time, let's begin. First of all, uRPF stands for what? So uRPF stands for Unicast reverse path forwarding. Path forwarding, guys, it is a feature on routers. It is a feature on router, right? We can configure it on router. Now first try to understand why we need uRPF and which type of attack uRPF can prevent. So let me write here. It is used to prevent DOS attack. If you guys know DOS attack, good. If you don't know, if you don't know what is DOS attack, please let me know in the comment section, right? That please make one video on DOS attack. Also I will make one video on DOS attack, right? Because uRPF can prevent DOS attack, or in simple word what we can say, it is used to prevent situation like CPU based attack, or you can say what, DOS attack, right? So in case you don't know what is DOS attack, please let me know. I will make one separate video on it. CPU based attack, what do you mean by CPU based attacks? First of all, try to understand this. So see guys, here I have one topology, one small topology, R1. This is my R1, router 1, router 2, and let's say router 2 is connected with ISP. Router 2 is connected with internet. Here router 2 is connected with one switch, and this switch is connected with one server. Let's say this is my HTTP server, right, or FTP server, or DNS server, or DHCP server, right, any server. And here on router number 1 we have two users, right? This is, let's say, PC1 and this is PC2. IP address of, let's say, PC1 is 10.1, IP address of PC2 is 10.2. Now let's say 10.1 is attacker, this user is attacker. So this attacker can spoof their IP address. This attacker can spoof their IP address, and after that this attacker can attack on my server, right? This attacker can attack on my server. Let's say if this attacker will send lots of SYN packet on this server by spoofing the source address. Let's say it have spoofed their source address to 20.1 to 20.2, right, to 20.3, right? They can spoof, right? There are multiple tools available on the internet, right? You can also use to spoof source address. So with the help of source address, this attacker can send lots of SYN messages on this server, right? SYN is a TCP SYN message, synchronization message, right? We used to establish three-way connection, used to establish, you can say, a TCP connection, right, by sending SYN message. So this attacker can send lots of SYN messages by spoofing their source address. And guys, on the server we have actually limited number of connection, right? This server can maintain limited number of connection at a time. Like you can communicate to how many people at a time? Max to max 2 people, 3 people, right? Not more than that. You cannot communicate with thousands of people or hundreds of people or 10 people at the same time. In the same way, server can also maintain limited number of connection at a time. Let's say this server have capability to maintain only 100 connection. 100, it can establish 100 TCP connection, right? So if this attacker will establish 100 connection with this server with a different source, right? With source number 20.1, 20.2, 20.3, right? With all sources, if this attacker will establish a TCP connection, then this is my actual genuine user, right? If then this genuine user will try to access the server, now server will send the reset message because connection is already full, right? This server cannot handle more than 100 number of connection at a time. TCP connection, I am talking about TCP connection. So this is what one kind of attack. This attacker have establish fake connection with the server so that genuine user cannot build TCP connection over here, right? Or you can say, let's say if this attacker this attacker IP address is, let's say, what, 10.1, and this user IP address is 10.2. here IP address is, let's say, 12.1, here IP address is 12.2. what will happen if this attacker will send, let's say, thousands of ICMP packets, or 10,000s of ICMP packet, or lakhs of ICMP packet with source 12.1 to 12.2. if this attacker will spoof their source to what, 12.1, right, and destination is what, 12.2, it will generate ICMP traffic, thousands of ICMP traffic with source what, 12.1. it have spoofed their source from 10.1 to 12.1, and then it have sent to router. Now what R1 will do, R1 will receive the traffic, and generally router check what, routing table to forward traffic. This is the main concept. Generally whenever router receive the traffic, it will check what, destination IP. So destination IP is what, 12.2. it will forward the packet to router number 2. Getting my point? And router 2 will reply to whom? Router 2 will reply to router number 1, right? So this router R1 and R2, both router will process thousands of ICMP packet unnecessary. So automatically CPU utilization of these devices will goes high, right? And on CPU utilization will goes high, performance will goes down. Getting my point? So this type of, to prevent this type of attack, we come up with this concept, uRPF, so that no one can spoof their source, right? No one can spoof their source. Like here, if I will talk about the by default behavior of router, by default router is checking what, destination IP address. When this user will generate ICMP traffic, this user IP address is 10.1, and let's say it have spoofed the source to 12.1, destination 12.2, right? So when this attacker will forward this traffic to router number 1, router 1 will check only destination IP address. Router does not check from where this traffic is coming, because source is what, 12.1, but router 1 will not check the source, it will check only destination IP address. Destination is 12.2, it will forward the traffic to router number 2. Getting my point? So to prevent this type of attack, we come up with what, uRPF, right? With the help of uRPF, we can tell to router, right? We can tell to router that whenever you will receive traffic on this interface, whenever you will receive the traffic on this interface, please check source also. Please check source also. If source is 12 or any network except 10 network, because here we are running what network, 10 network, 10.1.1.0/24 network. So what, whenever you will receive traffic with source different from this network, then discard it. Means, see guys, uRPF stands for what, unicast reverse path forwarding. Unicast means what, this feature is for unicast, this feature is for unicasting. And reverse path means what, it will check the reverse path, right? It will check the reverse path for the traffic. See, in the traffic source is what, 12.1, right? So when you will enable uRPF feature on this interface, we can enable it on interface basis. So when you will enable uRPF on this interface, after that, if router will receive any traffic over here, it will check the source address, right? It will check the source address. And reverse path forwarding, right? It will check the reverse path. Reverse path means what, if I need to generate reply for this traffic, will I forward the reply from same interface or not? Because if router 1 is receiving a traffic over here, right? So if router 1 need to generate reply, then router 1 should generate reply from the same interface, from the same interface, right? From this interface, router 1 should forward the reply from this interface only. But right, when reply will come, when router 2 will forward the reply, in the reply you can see, in the reply destination IP will become what, 12.2, source will become what, sorry, when router 2 will receive the traffic with source 12.1, destination 12.1. When router 2 will generate reply, source will become 12.1, destination will become what, 12. Sorry, source will become 12.2 and destination will become what, 12.1. Right, now router 2 will forward it to router number 1 and see what is the exit interface for 12 network. This interface, right? Not this interface. Getting my point? Exit interface is this interface for 12 network. Getting my point? Let me make you understand same thing in different scenario, right? Let me open my GNS3 over here. In GNS3 you can see, guys, I have one topology. Let's say this is client. This client IP address is 10.1.1.1, and if this client will spoof their address to 12.2, to 12.2. So let's say this is attacker. This is attacker, and this attacker is going to attack on router number 2 and on router number 3. Yes, this attacker can attack on these two routers at the same time. See how it will generate thousands of ICMP packets or lakhs of ICMP packet with source what is, it can spoof their source to 12.2, 12.1.1.2 and destination 23.1.1.3. It can generate, you know, telnet traffic also. It can generate any kind of traffic, right? Now this is my traffic. This attacker will forward this traffic to what, router 1. Router 1 will check their routing table. In their routing table, let's say here we are running what, any dynamic routing protocol, let's say EIGRP. In my scenario, I am running EIGRP routing protocol. Because of that, all IP addresses are reachable with each other. So in the routing table of router 1, there is one route available for 20 network, and exit interface is what, fast Ethernet 1/0. So router 1 is not going to check source, right? This is normal behavior. It will forward the traffic to router number 2. Right, router 2 will receive the traffic. It will check destination. Destination is 23.3. It will forward the traffic to router number 3. Router 3 will generate reply message. In the reply message, source will be what, 23.1.1.3 and destination will be what, 12.1.1.2. right? So router 3 will give reply to whom, to router number 2. Right, so router 3 will receive echo request. It will generate reply for router number 2, for router number 2. So this attacker is attacking on both router at the same time, on router number 2 also and on router number 3 also. It can increase the CPU utilization of R1, R2 and R3. R2 and R3. So in this scenario, how I can use, you know, uRPF feature to prevent this attack. Guys, I will show you this attack also, like how this attacker can attack on R2 and R3 at the same time. But before that, let me tell you how we can reduce this attack. If I will enable uRPF feature over here on this interface, uRPF feature on this interface. Normally router is uRPF. Normally R1 is receiving the traffic, it is checking destination and it is forwarding, right? But if you will enable the uRPF, it will check what, reverse path. It will check reverse path. Now when router 1 will receive this traffic with source 12.2, destination what, 23.3. Here uRPF service is enabled, so it is going to check the reverse path. It is going to check reverse path. If I need to forward the reply message, so it will reply to whom, to 12.1.1.2, to 12.1.1.2. So to forward traffic to 12.2, will I use same interface? No. For 12 network, I will use which interface? This interface as an exit interface, because 12.2 is here, right? So if I am not using same interface for the reply, then I will drop the traffic. If I am using same interface for the reply packet, then I will forward the traffic. Means if reverse path is same, then it will forward the traffic. If reverse path is not same, then it will drop the traffic. Now let me tell you some more theory part about uRPF here, and then I will, you know, configure it in this scenario. So let me write here some more points about uRPF. So what you can say here, hope now this is clear to you that why we need uRPF. So it is just to prevent CPU based attack or DOS attack. Now what we can say, uRPF is a feature which we can enable on per interface basis on router, right? Then whenever a router, guys, I'm writing everything in simple language so that you can also keep this definition in your mind, right? So whenever someone will ask to you, you can answer him. So whenever a router interface will receive traffic, it will look up for reverse path in FIV, in the FIV, right? If it is using same interface to send traffic back to the if it is going to send traffic back to the source, if it is using same interface to send traffic back to source, then it will forward. Otherwise it will drop the traffic, you can say, right? So this is, guys, concept of uRPF. Now hope it is clear to you, right? So what we can say in simple word, like what is uRPF? So you can say uRPF stand for unicast reverse path forwarding. Unicast means this feature is for unicasting, and reverse path means it will check the reverse path. If I am using same interface for the reverse, right, for the reply, then only I will allow the traffic, I will forward the traffic, otherwise I will drop the traffic. So let me configure this scenario. Actually this scenario is pre-configured. Here I am running EIGRP between R1, R2, R3. Because of that, all IP addresses are reachable with each other, means all routers are reachable with each other. Here I have access of all devices. Let me access, and now I am going to show you first how this attacker can attack. Okay, now from the client machine I am going to first ping 23.1.1.2. so let me check I am able to ping or not. On R1, so run interface F0/0. I think this is configuration. You can see uRPF is disabled. Okay, so on client machine, why I'm not able to ping? So IP interface brief. So here IP address is 10.1. Let me ping to gateway. Gateway IP address is 10.1.100. Yes, I am able to ping my gateway, and so run section IP default gateway is this one. Okay, this is also correct. Now on router number 1, so IP route, so we have 23 network, right? On router number 2, so IP route, so actually here we don't have 10 networks. So let me do one thing. On router number 1 I am going to advertise 10 network in EIGRP, so run section EIGRP. You can see I am not advertising 10 network in EIGRP. Okay, so this is problem. Let me do one thing here. Say router EIGRP is number 10 and network 10.1.1.0. Fine. Okay, now this client, from the client machine I am going to ping 23.1.1.2. so you can see I am able to ping R2, I am able to ping R3 also. right? Now I'm going to attack on router number 2 and router number 3, right, with the help of ICMP. So what I will do, I will first spoof my source. So to spoof my source, I'm going to create one loopback here. Let's say loop interface loopback 1. And guys, in real time, attacker can use different tools. There are lots of tools available on the internet that you can use to spoof source address. On this loopback interface, I'm going to configure same IP address which router 2 is using, 12.1.1.2 and 255.255.255.0, right? I've configured same IP address which is running on router number 2 on loopback interface. And now from here, I'm going to do one thing. I'm going to generate ICMP traffic, say ping 23.1.1.3. I'm going to ping router number 3 and say source is what? Source is loopback 1 interface. Loopback 1 interface. So source will be what? The IP address which is running on loopback interface, means 12.2, right? Destination will be what? 23.1.1.3, right? Now route in the traffic, source IP will be 12.1.1.2. Destination IP will be 23.1.1.3. This client machine will forward traffic to their default gateway, right, to router number 1. Router 1 will check their routing table. So IP route. Definitely we are not getting reply here, because who will generate reply? Router number 2, right? Who will generate reply? Router number 3. For whom? For router number 2, not for the client machine, right? For the destination in the reply message will be 12.2, right? Okay, so on the R1 will check their routing table. In their routing table, see, destination in the packet is what? 23.1.1.3, right? So for 23 network, exit interface is fast Ethernet 1/0. It will forward the traffic from fast Ethernet 1/0. Router 2 will receive the traffic. Router 2 is also going to check their routing table. In their routing table for 23 network, exit interface is what? Fast Ethernet 1/0. So it will forward the traffic from fast Ethernet 1/0 to router number 3, right? Router 3 will receive it, and router 3 will generate reply for 12 network, right? So here on router number 3, I'm going to debug IP ICMP just to show you that this router is generating reply for R2 or not. Here also I'm going to enable debug IP ICMP, and now from the client machine again I'm going to send some ICMP packet, right? Okay, so you can see router 3. On the router 3 console, you are able to see some ICMP packet. It is replying to whom? To 12.1.1.2. Router 3 is replying to 12.1.1.2. Source is 23.1.1.3. And on router number 2 also you can see router 2 is replying to whom? To 23.1.1.3. Source 12.1.1.2. Getting my point? So in the same way, client can generate lots of ICMP traffic. Repeat. Now, if I will hit enter, what will happen? Router 3 and router 4, both routers are going to, process this number of ICMP packet. Automatically CPU utilization of this device will goes high. Getting my point? See again on router number 2. Router 2 is replying. Router 2 is generating reply to 23.2 and router 3 is replying to 12.2. Getting my point? So this is CPU based attack. To prevent this attack, we have what? uRPF feature, right? Now on router number 1, I am going to do one thing. I am going to configure uRPF. As I told you, we will configure uRPF on interface basis, so I'm going to enable it on interface fast Ethernet 0/0. Here simply we can run command IP verify and then unicast, then reverse path, and then we can use access control list, leave it, right? We will discuss these things later. If guys you want detailed video on uRPF, please let me know in the comment section. Definitely I will make, because we have 2 modes as well in uRPF, loose mode and strict mode, so we can discuss those all in this video. Just I am discussing what is uRPF, right? Nothing else. So here on interface fast Ethernet 0/0, I have enabled uRPF feature. Now I'm going to clear here, and again I'm going to generate ICMP packet, but this time you can see on router number 2 we are not able to see any packet here, right? And on R1 if you will run command show interface fast ethernet 0/0, so on this interface you can see, so I think IP interface, so IP interface fast ethernet 0/0. In the last you can see IPVRF source reachable via RX, means VRF is enabled over here on fast ethernet 0/0. That's why this interface has dropped how many packet? 5 packet. It have dropped 5 packet. Again, if this attacker will generate ICMP traffic, again it will drop 5 packets. So you can see packet count is increasing over here. It have dropped 7 packet till now, right? So now router 1 will allow only that traffic on fast ethernet 0/0 where source is from which network? From this network, right? Because it will check the reverse path. So reverse path is means exit interface for reverse path is fast ethernet 0/0 only for which network? Only for this network, guys, because this network is connected on this interface, right? So from any other source it will drop the traffic, from any source it will drop the traffic. But again, from the client machine, if you will ping router number 3 with correct source, with source what? 10.1.1.1, so you can see ping is still working, right? So this is how you can enable it. So now hope it is clear to you, like what is uRPF. So guys, if you have learned something from this video, please hit on like button. That's all for today. We can discuss more about uRPF in another video, right? So that's all for today. If you have learned something from this video, please hit on like button, guys. We will meet soon in next video. Till then, stay safe. Bye bye. That's all for today.